In the summer of 1945, beneath rows of barbed wire and a fluttering stars and stripes, a group of captured German engineers stood around a grease-stained drafting table inside Camp Huntsville, Texas. They were supposed to be defeated men, enemy technicians whose knowledge had served the Reich. Instead, under armed guard and U.S. supervision, they were quietly redesigning America's machines. According to Army Service Forces records, their improvised tool jigs increased production output by 30% in several wartime plants. At Fort Lewis, Washington, a POW named Günther Graver devised a casting mold so precise that an American foreman called it better than Detroit's. Even the Provost Marshal General's own summary noted with astonishment, the efficiency of enemy technicians exceeded expectations of civilian supervisors. No propaganda could have prepared either side for that paradox. German captives strengthening the arsenal of their conquerors. Declassified documents show how U.S. officers initially hesitated to allow any precision work, fearing sabotage. But the results spoke for themselves. Equipment failure rates dropped, assembly lines sped up, and factories from Iowa to Alabama requested more skilled mechanical laborers from the camps. By late 1946, the Army admitted in Technical Report T-1443 that German prisoner ingenuity contributed directly to post-war industrial development. The men who had once built weapons for Hitler were now improving America's peacetime machines under the watch of sergeants with rifles. It was a story of reversal so unlikely that even historians would later question how it could have happened. How did captivity become collaboration? How did barbed wire become a laboratory for American innovation? To understand this astonishing documented turn of events, the official records show where it all began, inside those workshops of war turned factories of ingenuity. Before their capture, the German engineers who would one day labor behind American fences came from a nation convinced that its mechanical genius could never be surpassed. The Reich's industrial doctrine rested on the precision of its draftsmen and the mathematical discipline of its machinists. OSS intelligence files from 1944 describe an engineer's army, men trained to measure tolerances within 1/1000th of an inch, steeped in the belief that German design was a science superior to any foreign imitation. In the words of Armaments Minister Albert Speer, our technical superiority remains the guarantee of final victory. For years, that superiority had seemed indisputable. The Panzer divisions rolled on engines assembled with surgical precision. Messerschmitt factories produced aircraft parts so uniform that American inspectors later used them as calibration samples. A 1943 Allied economic report concluded grimly, German tool production efficiency exceeds U.S. standards by approximately 20%. Fueled by that data, Nazi propaganda painted Allied industry as clumsy, mass-produced, and soulless, incapable of matching German craftsmanship. Captured diaries from Wehrmacht technicians reveal the same conceit. The Americans build quickly, but not well. Their bolts break. Ours fit forever. It was this mindset that crossed the Atlantic in boxcars filled with defeated men. When the first contingents arrived at American ports in 1943 and 1944, they carried not just fatigue and ration tins, but an ingrained faith in Teutonic precision. Even inside barbed wire compounds, the arrogance persisted. Camp Hearn's chaplain recalled a POW engineer declaring, "We could rebuild your tractors properly if you'd only let us." At that moment, U.S. officers dismissed such talk as bravado from men in denial. What no one yet realized, not the prisoners, not their guards, not even the industrial officers overseeing their work assignments, was that the same confidence which once fueled Nazi ambition would soon be redirected under American supervision. The enemy's belief in its own engineering supremacy was about to collide with a system that prized innovation over hierarchy. And out of that collision, history would record one of the strangest partnerships of the entire war. By 1944, America's industrial miracle was showing signs of strain. The same factories that had outproduced the Axis now faced a crisis of manpower. Skilled mechanics, toolmakers and engineers had traded factory floors for foxholes in Europe and the Pacific. War Department figures confirm a deficit of more than 1.5 million trained laborers. In Washington, the War Manpower Commission issued increasingly urgent directives. Industrial output has plateaued. Skilled labor deficits must be offset by unconventional manpower. The solution that followed was as pragmatic as it was ironic: the employment of captured enemy specialists. Under the Geneva Convention's Article 27, prisoners of war could perform non-combat labor if paid and supervised. Initially, this meant fieldwork, harvesting crops, cutting timber, repairing roads. But by 1945, with American production bottlenecks threatening the arsenal itself, factory requests began to flood the Provost Marshal General's office. Official camp logs from Herne, Huntsville and Algona document repeated appeals for mechanical assistance from qualified prisoners. Many in Congress resisted the idea. The public, still raw from battlefront casualties, bristled at the notion of enemy engineers repairing American machines. Newspapers called it arming the captured hand. Yet industrial necessity overruled sentiment. "Better to have a German turning our lathe," wrote one War Production Board official, "than have a soldier waiting for parts that never arrive." When the first technical work groups were authorized, they operated under tight guard. Each project was inspected by U.S. Army Service Forces officers, every drawing and design scrutinized for sabotage. But as early reports returned from the camps, something extraordinary emerged. The prisoners' precision, the very skill that had built the Luftwaffe and Panzer Corps, was now improving American machinery faster than anticipated. In secret memos, commanders began to note the irony with a mix of disbelief and admiration. The enemy's tools now serve our victory. Behind the guarded gates of America's POW camps, a quiet experiment unfolded, one that would never appear on a victory poster. By late 1945, the Office of the Provost Marshal General authorized what it called controlled technical labor. In plain terms, that meant turning enemy engineers into problem solvers for American production lines. According to Army Service Forces Technical Report T-1443, more than 2,500 German prisoners were reassigned from farm fields to engineering sheds equipped with lathes, drafting tables and supervised tool benches. At Camp Huntsville, Lieutenant Colonel George B. Powers oversaw one of the earliest experimental work units. He later wrote, "These men think in steel and ratios. It would be folly not to use their minds." Under his direction, German technicians redesigned a pulley alignment jig that increased throughput on Army truck assembly lines by nearly a third. Farther north, at Camp Algona, prisoners developed a more efficient, sand-casting mold used for replacement engine blocks, a design the U.S. Ordnance Department quietly patented after the war.declassified memos revealed that the initiative was not officially publicized. American officials feared public backlash if it became known that enemy engineers were improving domestic machinery while veterans still returned home. The files were marked for internal evaluation only, yet the results were impossible to ignore. By early 1946, maintenance reports across multiple depots recorded a 22% reduction in equipment, downtime linked to POW origin modifications, industrial. Officers soon realized the prisoners' habits of precision and documentation mirrored America's emerging post-war production philosophy, efficiency through design simplicity. The Germans' emphasis on tool calibration and modular assembly dovetailed perfectly with U.S. mass manufacturing logic. Camp instructors began documenting the processes, creating the Army's first technical work group manuals, later circulated to civilian contractors under different covers. Historians would later note the strategic irony. The nation that defeated Germany on the battlefield was now absorbing its engineering discipline under guard towers and floodlights. In workshops surrounded by barbed wire, the defeated were quietly helping refine the machinery of victory. As one War Department memorandum concluded with understated satisfaction, results justified discreet continuation of technical assignments. What had begun as a temporary experiment was fast becoming a blueprint, not just for repairing equipment, but for re-engineering American industry itself. By autumn 1945, the U.S. Army had refined the strange new system into an organized routine. Technical work camps were no longer improvisations. They were carefully structured industrial laboratories. Circular 7245 outlined every detail, from tool issuance to daily inspection reports. German specialists were grouped according to expertise: machinists, draftsmen, metallurgists, electricians. Each cell worked under a paired American supervisor who monitored every measurement, logging progress in duplicate forms filed to Washington. At Camp Hearn, work began before sunrise. Prisoners marched from their barracks under guard, entering large corrugated iron sheds retooled into workshops. Inside, the air smelled of oil and metal filings. Under fluorescent lights, the men bent over precision lathes and drawing tables, producing component sketches stamped POW Restricted. Captors James Auer, who oversaw several projects, recalled, "Every bolt, every drawing, every scrap of metal was checked twice, once for precision, once for intent. Security was absolute. Every doorway had a sentry. Windows were screened. Finished parts were transferred in sealed crates marked with serial numbers corresponding to inventory sheets. Even the weather appeared in daily logs. Weather clear. Worksheet secured. Test run completed successfully." The documentation reflected both military discipline and a subtle recognition of value. What began as a small technical trial was fast expanding into a logistical network stretching from Texas to Washington state. Enemy communications, intercepted and translated, show that German officers back home remained oblivious. They assumed their captured men were toiling in fields or kitchens, not redesigning American manufacturing processes. But American reports tell another story. Multiple camps achieved production quotas, exceeding civilian plants by measurable margins. As 1946 approached, the Army prepared to formalize the system, establishing specialized technical detachments to coordinate results nationwide. The stage was set. The barbed wire laboratories were ready for their greatest test: full integration with active American factory lines. In February 1946, the experiment crossed the wire. Crates stamped POW Restricted left Camp Huntsville under military escort, bound for an Army depot outside Mobile, Alabama. Inside were pulley alignment jigs and mold assemblies designed by captured German engineers months earlier. They were about to face their first real trial, the American factory floor. The plant foreman, a man named Charles H. Lang, admitted later he had expected failure. "We assumed it would jam on the first run," he told investigators. But when the machines began their cycle, the line didn't slow. It accelerated. Production sheets recorded a 27% increase in output during the initial 12 hours. Maintenance crews logged 0 malfunctions. The same week, identical results emerged at Fort Lewis, Washington, where a POW-devised casting mold produced engine blocks so precise that the Ordnance Department's micrometers barely registered deviation. E.T. Kohler's George B. Powers, overseeing the test, sent a terse but revealing cable to Washington. They solved a problem our draftsmen had argued over for 6 months, in 2 days. According to the War Department's Industrial Division log, American supervisors reacted with equal parts disbelief and admiration. One entry reads, "Performance of modified jig exceeded specifications. Morale among American crews notably improved. To ensure security, guards surrounded every test site, and reports were circulated under confidential headings. Yet, within weeks, whispers spread through the service forces. The enemy's tools worked better than expected." OPMG's evaluators summarized it bluntly: "Enemy technical efficiency, unexpected, undeniable, and instructive." The impact rippled through both camps and command posts. At Herne, German prisoners were permitted to read anonymized results translated into German. Witnesses recall their silent pride. "We felt," said former POW engineer Kurt Newman decades later, "that for once our skill built something good." Meanwhile, War Department planners debated how to proceed. Some officers urged immediate replication, others feared public outrage if word leaked. In Washington, the memo trail shows hesitation giving way to pragmatism. The directive dated March 28, 1946, authorized continuation of technical labor under classification restricted industrial applications. The victory was not fought with tanks or bombers, but with blueprints, ratios, and the hum of retooled machines. In the annals of war, it was a confrontation unlike any other, a battle of precision rather than firepower, where the outcome was measured not in casualties but in revolutions per minute. And when the final tallies were filed, the record left no doubt. Inside America's factories, behind layers of secrecy, the prisoners had won a quiet, mechanical triumph, one that would reshape post-war production long after the camp gates swung open. When the first ships bearing repatriated prisoners docked at Bremerhaven in the spring of 1946, the men stepped ashore carrying more than duffel bags. They brought stories that unsettled what remained of Germany's professional pride. In debriefings recorded by Allied Control Council officers, returning engineers described guarded workshops in America where their designs had been tested, improved, and, most astonishingly, adopted. The reports filtered through ruined factories and shattered ministries like sparks in ash. German industrial officials initially refused to believe it. The Reich's pre-war doctrine had been built on the conviction of unrivaled precision. Yet the documents in their hands, army blueprints bearing unmistakably German metric annotations, told another story. One repatriate, Dr. Hans Riehle, wrote in a 1947 letter now preserved in the Bundesarchive, "They let us think, and that was their greatest weapon." American intelligence summaries confirm the psychological impact. A War Department memo from April 1946 noted, "Returned personnel report morale shock within German technical circles upon learning of U.S. industrial use of POW specialists. Interviews collected by U.S. intelligence agents revealed recurring themes of bewilderment and reluctant respect. Many Germans admitted that while they had considered American mass production crude, they now recognized its adaptive genius, the willingness to integrate even the ideas of former enemies. In occupied Germany's engineering schools, instructors quietly cited the episode as a lesson in humility. The myth of the infallible German engineer had been pierced not by propaganda, but by the undeniable evidence of results. Ironically, several of the same men who once designed weapons for Hitler would later assist in rebuilding German industry under American oversight, applying principles refined behind U.S. fences. From Berlin to Bremen, the realization spread. The war had not only been lost on battlefields, but in workshops where innovation itself had changed sides. The shock was complete and irreversible. Within months of the final POW transports departing, traces of their work began to surface across the American industrial landscape. The U.S. Army Service Forces compiled its closing summary, Technical Report T-11443, and quietly forwarded copies to the Department of Commerce and major defense contractors. Buried in its annex were 6 mechanical improvements, credited to foreign technicians under supervision, including a recalibrated pulley housing and a modular mold casting system that soon appeared in civilian. Catalogues without attribution, factory, managers who had once doubted the program now requested the same production guides. By early 1947, the Army's technical work group manuals were reissued in civilian form as industrial efficiency handbooks, distributed to more than 200 manufacturers. Department of Commerce analysts later estimated that process refinements derived from the POW projects boosted post-war plant efficiency by roughly 15%. These innovations arrived at a decisive moment. America was shifting from war to peace, from tanks to tractors, and every saved man-hour mattered. The War Production Board's internal memoranda described the transition as the most complex reconversion in national history, yet note repeatedly that methods tested under controlled labor conditions eased the adjustment. Behind that phrasing lay the unspoken truth of the barbed wire laboratories. Military observers also saw strategic implications. The Ordnance Department incorporated several POW calibration methods into its 1948 technical training curriculum. One officer's marginal note, preserved in the archives, reads simply, "German precision married to American scale." Publicly, the collaboration remained a classified curiosity. The files carried restricted markings until the early 1950s, when fragments appeared in engineering journals stripped of wartime context. But within America's factories, the influence was unmistakable: tighter tolerances, modular assembly, and a growing respect for the disciplined precision once considered purely German. In effect, the United States had absorbed its former adversary's best habits while maintaining its own genius for speed and adaptability. The immediate result was prosperity. The long-term consequence was a quiet technological inheritance that would soon propel American industry and its military machine into the Cold War era with an efficiency unmatched anywhere on Earth. When historians began to re-examine the industrial dimension of World War II, the story of the German POW engineers emerged as one of its strangest and most telling episodes. Official monographs from the U.S. Army's Center of Military History describe it as a controlled encounter between two philosophies of production: the German faith in precision and the American obsession with efficiency. Together, they produced results that neither system could have achieved alone. By the early 1950s, the lessons drawn from those camps had quietly filtered into industrial and military policy. Declassified memoranda from the Ordnance Department encouraged officers to pursue cooperative design methodology, explicitly citing the 1945-46 Camp Huntsville model experiments. Meanwhile, universities such as MIT and Purdue incorporated case studies on adaptive innovation under constraint, using sanitized data from the POW programs. A 1954 Army monograph concluded, "The workshops behind wire proved a greater victory than any captured weapon." Across the Atlantic, former prisoners applied what they had learned under American supervision to rebuild their own shattered industries. German Federal Archives records show that by 1952, at least 17 engineers formerly held in the United States were employed in reconstruction projects funded by the Marshall Plan. Their reports emphasized standardization, modular tooling, and cooperative planning, principles they had refined during captivity. Günter Grave, once a POW draftsman at Fort Lewis, told a journalist 2 decades later, "Our captivity taught us cooperation. Our designs survived in freedom." Scholars now view the episode as an early form of technological globalization, forged not through diplomacy, but through necessity. It blurred the line between victor and vanquished, transforming intellectual capital once used for destruction into a shared foundation for prosperity. In Cold War NATO logistics workshops, American officers even referenced the Camp Huntsville precedent when promoting cross-national standardization. The legacy extended beyond machines. It challenged moral and psychological assumptions about warfare, captivity, and the boundaries of knowledge. A paradox became a principle. Ideas could outlive ideologies. As one historian summarized in a 1978 lecture, the Americans captured more than men. They captured a method. Today, the files of those wartime projects remain largely unknown to the public, but their influence endures in every factory that prizes both speed and precision. Beneath the victory parades and post-war prosperity lay an unacknowledged alliance, born in confinement, built on respect and proven in steel. The story of the German engineers who improved American machinery while still prisoners remains one of the quiet marvels. of World War II. It began with suspicion and necessity, and ended as proof of a universal truth recorded in the War Department's own motive summary. Innovation is not a nationality, it is an act of mind. Within 3 years, more than 7.3 million labour hours had been logged under the POW program. Each hour a small fragment of an industrial renaissance that would outlast the war itself. In the archives at Carlisle Barracks, the technical work group reports sit beside maps of Normandy and Okinawa, a reminder that victory was forged not only on battlefields, but in workshops where courage took the form of creation. The same men who once built weapons for the Reich ended up designing efficiency for democracy, proving that ideas can survive captivity and even redeem it. Today, the Smithsonian's modest exhibit, Captured Labour, Innovation Behind Barbed Wire, stands as testament to this paradox, proof that ingenuity transcends allegiance. It challenges us to see history not as a chain of conquests, but as a dialogue between enemies who, for a brief and unlikely moment, built something together that neither side could have imagined alone. For viewers and historians alike, the lesson is enduring. Strength lies not merely in weapons or numbers, but in the willingness to learn, even from one's adversary. America's ability to absorb, adapt, and elevate foreign knowledge turned defeat into innovation and enemies into contributors. As we look back, the barbed wire has rusted away, but the designs remain, quiet witnesses to a victory measured not in destruction, but in creation. To honor that legacy, we must keep studying, questioning, and remembering that the truest power of any nation lies in how it transforms knowledge into progress.